What's up, YouTube? It's your favorite math teacher, Mr. Stevener, coming at you with another video. Check it out. This one is challenging, okay? This is actually dealing with system of equations, okay? And this basically, system of equations, we're going to jump right into it. Don't forget to hit that subscribe button. System, or systems is what they might call it, of equations. Okay, that basically means there's multiple equations and you're trying to solve them. Okay, and it wants to know basically when you take those equations, where are their solutions or where are their answers equal? And there are three different situations for this. Okay, I'm gonna give you the first situation. All right, first situation is when you have an equation like y equals, we'll call it 4x plus 9. And another one, maybe y equals 3x plus 6. And it wants to know, okay, what is the solution to this system of equations? So basically what it's saying is, how are these two, what is the one answer that both of these are equal to? And the only way to solve that is to set them equal to each other. And here's why. Like, I want you to think about this a second. This says y is equal to 4x plus 9, right? It also says y is equal to 3x plus 6. So this is saying that y is equal to both of those things. If that's true, that means you can say 4x plus 9 is equal to 3x plus 6. All I did was realize, well, wait a second, if y equals this, then I can put it right there, right? Because this part says y. This is one of the ways to solve system equations of many ways. But you find a solution. You solve it. I've made videos on this. This is solving equations with variables on both sides. Go check that video out up there. First thing I'm going to do is I want to get the x term to one side. So here we go. I'm going to get rid of this. The only way to get rid of an x term is to subtract it, right? That's to get rid of it. Do that to both sides. So I now get over here 4x, take away 3x is x. X plus 9 equals 6. Right now I'm going to still need to get that x term by itself. Okay, this guy's in the way. All right, so I'm going to subtract 9. That's how you move a term, get rid of it. And you end up getting x equals -3. So this problem right here has one solution at x equals -3. Okay, so this is one of the scenarios, because there's three different ones. This is the first one, and that's when there is only one solution. Okay, and let me explain what I mean by that in one solution with the system of equations. Okay, if I were to graph this, which I'm going to start with this one, 4x plus 9, that crosses the y-intercept is 9, so it crosses right here at 9. Okay, and the slope is up 4 over 1. Okay, I want to see what happens when I put in 1. So if I put in x is 1, y is 13, so that's like up here. If I put in, let's put in -1. All I'm doing, guys, is plugging in numbers into x, but I'm just doing it in my head. So 4 times -1 is -4 is 5. So this -1, wait, did I do that right? Yeah, 5. So I'm going to just do that, and then we'll do -2. -2, 1. Okay? So now I got this line. Mind you, I can't connect that one because 13 is way up there. But I got this line that is a terrible straight line that looks like that. I graphed that one. Okay? Now I'm going to graph this other one. It crosses, let's do a different color. It crosses at 6. So it crosses right here. Okay? And if I use do 1, it's 1, 9, which is right here. Right? If I do -1, it's -1, and -1 times 3, right? I'm plugging in -1. All I'm doing is this. I'm plugging x in, and then I'm solving it. It's like I'm creating an xy table, and I want to know, where does it cross? Okay, so that crosses at 3. So -1, 3. All right. Now, when I go to draw these lines, what this is saying is those lines are going to connect. That's a terrible straight line. Holy cow. They're going to connect at a certain point. And it looks like they connect right here. I know that's terribly not straight. It's really hard to draw a straight line on this. But you'll notice where they connect. Well, this is at -3. Right? That's because this one solution is where these lines cross. What we're looking for is the solution is wherever a line happens to cross. That's the solution. That's an example. Okay? So here's one of them. It's one solution. Okay. The other option is when you get something like this. Now, a lot of times you're going to see this in different forms, but you'll say y equals 3x plus 6, and then the other one it might give you is 6y plus math. Oh, 18x minus 18x equals 36. Right? Again, we make something like this, and you have to solve this. Don't panic. Okay, this is in a standard form. Okay, you can actually turn this into the y equals 3x plus 6 form. Okay, the way you do that is you solve for y and get it by itself. Okay, you can handle that. Check it out. So this happens when I do this. I'm going to say, okay, wait a second. I want to get y term by itself, so I'm going to move 18x. I'm going to move it all the way over here. So 6y equals 18x plus 36, right? Now I'm going to divide each one of these by 6, right? Divide by 6, divide by 6, and you're going to get y equals 3x plus 6. Now, if you'll notice, okay, this right here and this right here are the exact same thing. So when I go to set those equal to each other, I'm basically going to get the 3x is going to cancel. Well, that's weird. That disappeared. And the 6 is going to cancel. Why is that? That's because these lines are the exact same. Okay, the 6y minus 18x equals 36, and this line are the exact same thing. Well, so how many solutions does that have? Well, you're going to see that, pretend this is the line, right? If I graphed this one, and then if I graphed this one, well, that line is right on top of that one. So they're literally the same line, which means it has infinite amount of solutions. So the second option is that it has infinite amount of solutions. That's because it's the same line with the same slope. You with me on that? So the first one, just one solution. The second one, it has infinite solutions. Okay? And the last one would be something like this. Okay, so if I said y equals 5x plus 9 and y equals 5x plus 3. Hopefully you notice that if I go to solve these, I plug them into each other. These have the same slope, right? But they don't have the same intercept. Okay, so watch what happens if I try to solve these. I'm going to set them equal to each other. 5x plus 9 equals 5x plus 3. Right? I try to solve. I'm going to move 5x. Uh-oh. I move 5x, and 5x disappears, and this gets 9 equals to 3. Is that true? No, 9 doesn't equal 3. That's impossible. So if that happens, right, if it has the same slope, the same mx, right, for the y equals mx plus b, if it has the same mx, that means there are no solutions. It cannot be solved. And that's because they're parallel lines, right? Because I have a slope that this one crosses at 9 and goes something like this, right? Well, this one crosses at 3 and goes something like this. These lines don't have any solutions because they're parallel. They're absolutely never going to cross. Okay, so those are the three things that you will see with systems of equations, the answers for system equations. There are many ways to solve system of equations that we will get to, but this is just, if you set them equal to each other, does it have no solution? Does it have infinite solutions? Or does it have just one solution? Hope this video helped, guys. Hope it didn't go too fast. If you guys have questions, feel free to comment them. Comment. See you for the next video.